And hello everyone, welcome back to CSC 151. In the last video I gave a little mention about this area right over here with the drive and the if we cross finish line, that I actually kind of showed you a little bit of something that we have not done yet. And that thing is known as a loop. So let me go and keep just deleting all this, and we'll start off with a new video, a new little bit here to discuss what loops are. Loops are essentially something that continues on forever. So, for example, if I had a process of some sort, and let me just say, I don't know, what do I want to use for a process of some sort? I'll use, that's not a step, where's the format? There's document. I'll use document, why not? I'll use purple document. And in this, it just simply says, add 1 to coins. Because, we've all played enough video games to know that once you get 100 coins, you get a 1-up. Well, whenever you touch a coin, boop, 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 it goes back, and it goes back to just itself. It goes back to adding 1 to coins. And that's really all it is. It just keeps going boop, 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 boop. Keeps going. So you get 100 coins, you get a 1-up. Ba-ding! Then it becomes a 0, and it goes boop, 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 boop. Now, here's the thing, considering all those new Nintendo games track the number of coins you got, it's not actually going to 0, you're just seeing the last 2 digits of the number. It can actually go up to like 50 bajillion. But, so we have ourselves that sort of situation where we have ourselves our code. It goes step 1, step 2, step 3, and then at step 3, or whatever step it is, it goes and says, go back to step 1. This is in of itself a loop. So let's just think of it like, what's a good example that I could use for this? Pac-Man. Pac-Man never ends. Now, technically it does end at level 256 because the computer runs out of space and the game breaks. But in theory, Pac-Man will never end. In theory, Tetris will never end. So, here's like, Tetris Tetris plays, whatever. And the blocks come down, do, 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 do. And then, of course, it gets faster. Or you clear lines or whatever. Clear lines gets faster. And then after it gets faster, you keep playing. You clear more lines, it gets faster. And then you play Tetris, still, you clear a lot more lines, it still gets faster. You keep playing, you clear more lines, it gets faster. So on and so forth. This process will never end. Those of us probably died at like level 10, level 11 maybe. When it got so fast, eventually you were going to just die. But you can keep going forever and ever and ever in theory. It is a loop. It will never ever end. Now, there are some examples of this that you can use in Lightbot as well, for those of you that do want to buy the game and play it. Let me see if I can find an example here of what I want to show you. Lightbot, let me do this, recursive. Here's an example of recursive code right here. In this box right here on the right, function 1 is light bulb turn forward, 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 function 1. What does that mean? Well, that means function 1, go back to the start of function 1. So function 1 calls itself, and that is what's known as recursive coding. And I'll just put that word up there, recursive coding. Recursive coding is literally a section of code that calls itself. So if I had, step 1, I'll just say step 1, step 2, and we'll do it this way, step 1, step 2, and then, copy, paste that down. Step 3, and then whatever's happening here, we'll make this a diamond. We'll make this a diamond, and we'll go and, go this one and something or other. Actually, no, we won't make it a diamond. We won't make it a diamond. We're not going to worry too much about it. Actually, yeah, no, keep the diamond. Keep the diamond. I decide to keep the diamond. We have some sort of condition that allows us to go this way and this way. Okay, just so we have ourselves a little break here. Because we could, in theory, have two things happening at the same time. So, over here is step 5 or whatever. Here's step 4. And something along this path said, go to, I don't know, A1. Because it's part A. This was, there was no letters. This was letter. So, A1, here we go. A1. And then we've got ourselves our good friend, A2. And then at A3, there is some sort of code that literally just says something along the lines of like, go to A1. So the program A1 ends with it saying go to A1. And that while this other bit of code is doing whatever it is it does over here. This right here is a recursive code. It is a code that calls itself. And you'll see those sort of loops in various sort of things whenever you have something that's happening simultaneously. Okay? So, tell you what, we've all know about Pong, right? We've all played Pong at some sort of process. If not, let me just remind you about Pong. This is Pong. Boop, 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 boop. Ball goes back and forth. Now, while this ball is going back and forth, we've got ourselves these little questions that we could always ask ourselves, where it's like, did ball exit playing field? And if the ball exited the playing field, then, someone gets a point. So somewhere along the lines we'd have something around, add 1 point or something like that. There's all this sort of stuff that's happening generally where we've got ourselves all these different questions about playing Pong and the general rule of thumb about Pong. But at the same time, there's something else that's always happening. The ball is consistently getting faster. So somewhere out there is a something or other that's saying, increase speed. And then there's a timer that's happening. So, start timer. There's a timer that's happening somewhere along the lines. And once that timer reaches 0, or count down, or if it counts up, start timer, increase speed, and then, it'll reset timer. So something's happening where there's a time limit, and then at the end of the time limit, the speed increases, and then the timer resets to start the time again, and to keep increasing the speed. The reason why they do that is to make it so that eventually, your human reflexes will not be fast enough to keep up with the ball. Eventually, someone is going to have the ball exit their playing field, and someone's going to score a point. But this part right here is basically a completely separate function from this over here, the rest of the logic of this game. And this part right here is a recursive loop. It is a loop that keeps going over and over again, independently of whatever's happening with the rest of the game. And that is what loops are. Now, you can set loops to have a start point and end point. So basically basically think of it like this. We could do something like, if x is, less than 1, we'll have a countdown timer here. If it's less than 1, well, then we'll have, end, something like that. It goes, countdown timer goes down to 0, so boom. Because, the countdown timer always explodes in a video game, right? So if x is not, so if it is less than 1, then yes. But if it's not, we can, do ourselves a loop of some sort. We can, count down, x will now equal x minus 1. Because, we'll say like we'll say x started at 10. We'll say x started at 10. We got ourselves a countdown timer starting at 10. So we'll say x equals 10. So if x is greater than 1, so if it's less than 1, we go boom. But if it's not, we make x lower. And then we simply go back to this loop. So we start at 10. Is it less than 1? No. So now the x is now 9. Is 9 less than 1? No. Now it's 8. We're keeping going on the loop. Is 8 less than 1? No. 7. No. 6. No. 5. 4. 3. 2. 1. Boom. There. That is a loop. A loop and an if statement. A conditional branch of logic that has made ourselves some sort of just a countdown timer of some sort. This is the visual representation of code to make a simple countdown from 10 to 1. And then go boom. And I guess, you lose a life, restart the level. But that's basically what this is. We are just doing the visual representation of a code that repeats itself. And that is, the other type of thing that we have to think about and look out for when it comes to designing our code. What processes are processes that repeat? Do you really want to write 100 different possible things when you can just write one? Yeah, just writing one. If it repeats, it repeats. I mean, if you're having a number game of guessing from 1 to 100, do you really want to calculate all 100 possibilities? Or do you just want to calculate one and have that one possibility repeat until you finally get the right answer? It's much less code to just simply have something repeat. Because I could have done, if x equals 10, no, okay, x minus 1, copy, paste, do something like that. I could have gone down, and because now it equals 9, and then I would have to, do this, and this, and copy and paste, copy and paste it, bring it down like this, and then copy and paste it again, bring it down like this, copy and paste it again, bring it down like this. I mean, already, just by looking at this visual demonstration, would you really want to write out all that code in order? And that's just from going from 10 to 0. So we're at 9, now we're at 8, now we're at 7, now we're at 6. Yeah, no, that would be ridiculous. It's much easier, much easier to simply stay with the loop and have the loop finally end at your command. So make sure we think about things like this when it comes to these projects. So that's a lot about diagrams. Let's go over some general rules of diagrams in the next video, and then let's start putting it together. Let's put it all together into an actual project. So I'll see you guys in a little bit. Thank you very much. Enjoy the next video.